we're actually continuing to solve NLP problems rather than just work on the software and only work on problems that we invent or common benchmarks or something like this. I think that really doesn't let us do something that's meaningfully different than the tooling that would be produced in academia, for instance. I think that connection with real problems was very important to Spacy initially, and I think it's eventually that well of experience that we had working on real problems started to feel like it was running dry, and we needed to have that contact with real problems, and especially as these new methods are available, we need to know, all right, how do we really use LLMs in these ways? Do we, the recommendations that we're making or the ideas that we have, we need to be able to actually test those and, keep our hands dirty with real problems.
Hi, friends, and welcome to Leading with Data, the podcast where we explore the transformative power of data in driving innovation, shaping decisions, and leading change. I'm your host, Kunal Jain, and each week we bring you insights from thought leaders, industry experts, and data enthusiasts who are at the forefront of the AI revolution. Today, I have with me Dr. Matthew Hannibal. Matt is the founder of Explosion.ai and holds a Ph.D. in computational linguistics from University of Sydney. If you've been working in NLP, you might know Matt as the creator of extremely popular library Spacy. So join us as we deep dive into a fascinating conversation with Matt about the future of data, Spacy LLM, challenges with current LLMs, and his views on how he sees AI in the future.
Thanks. Glad to be here and to catch up again.
Great. So, Matt, I would want to almost start back when we last met. So, June 2019, GPT-2 was out there. Spacy was the library for a data scientist to go to, and then still very popular. Since then, how has the domain evolved from your perspective, both at a macro level and from your company and in Spacy Library specifically?
Well, there's obviously been a lot that's happened in NLP since then, and it's hard to pin down exactly which bit to talk about. So I would say, if I'm thinking about the journey of NLP more broadly over the last few years, or 5 or 6, I sort of divided into a few key moments or ideas. So one of the watersheds where we really gained something and things moved forward a lot was around when deep learning started to really work, and we had not just the word to vec models, but then also pre-trained transformers like BERT. And the advantage of these models was that they were able to be initialized from unlabeled data very effectively. And you were able to then have relatively few examples of your problem, and you were able to train a task-specific model this way. So the reason why this is such a big deal is that before that, if you were learning anything new with language, the model was trying to learn not only some association between words and your label space, but also the association between the words themselves. So it's trying to learn things like, hey, this word is a synonym for this other word, or these words together in this order mean something different, or this phrase is, what we call in linguistics non-compositional. It means something different than the sum of these words together. So it's some expression or something like this. And language obviously is full of this. So having the ability to start with some knowledge of the language and then apply that to knowledge of the task was just a huge step forward. So this is around one of the key blog posts that was written about about this turning point was Sebastian Ruder's NLP's ImageNet moment has just arrived, and then all of the associated stuff around transformers that grew up around that. And then much more recently, since then, we've had this second turning point around what we now call large language models. And the terminology for this gets a little bit confusing because the other technology that we were talking about were, language models. Like BERT was trained on a language modeling objective, and you can see BERT as large or small. It's like whether this is kind of a matter of perspective. But we're now really talking about things like GPT-3 and GPT-4, and the big difference there, I think, is the in-context learning. So this is the ability to pose a question in natural language and have that sort of elicit some behaviors, including classification or some sort of structured output. And so there's obviously multiple ways of using these models. One including things which are just strictly for text generation. But what's interesting is this ability to use them as kind of this classifier approach or getting structured data out of them with only a few training examples or something like this. So the question is okay, so where does that leave us, or where are we in NLP at the moment? And I think it's a difficult time at the moment because it's still unclear exactly what direction things will take. And my perspective on this is that if we're talking specifically about classification problems and things, that we still actually there's still a big technical advantage to training models and to have essentially to do the gradient descent, to have a neural network architecture that's specific to a task that outputs say 20 neurons for 20 classes or something like this, as opposed to only doing in-context learning. And I think the in-context learning shines better for many NLP tasks as more of a prototyping tool or a data collection tool and things like that.
And the more niche a domain is, I guess, the better the outcome of your own trained model would be. So if you're looking at, let's say, medical data or something which is not general, then the approach of training your own model would probably be a lot better approach.
So
Is that?
it's a function not only of the domain, but also the task. So
Mhm.
you can get in-context learning to look really good if you give it tasks where actually it's not really doing in-context learning. So for instance, if you prompt a model about, say, label the sentiment of these tasks or something like that, the task description there is actually sentiment analysis is something which the model has understood something about from reading the internet, right? Like there's Wikipedia articles on sentiment analysis, and so this gives it a pretty good idea of what labels you're actually trying to assign. It's a non-arbitrary task, whereas a lot of classification problems, you've got these 5 or 6 buckets or something like this, and the definition of that bucket is actually the stuff within it. You can label it something, and those labels are kind of useful descriptions for a human. But ultimately, what you want to do is to actually reproduce that classification system. And so, if you're doing something like that, and especially as you get way more labels, for text classification, you might have 30 labels or something. Giving the definition of these 30 labels in a prompt is not really, it doesn't really work well. And that's where so it's these sorts of things where it might be a completely ordinary domain. It might be, working off Reddit or Twitter or financial news, which, certainly, GPT-3 and 4, know perfectly well. It's a question of what you're trying to do. So, the in-context learning learns a very deep representation of the text, but then it has a very shallow ability to actually learn a transform of that to a labeling scheme. And for many tasks, you want the representation of the text that you need can be relatively shallow, and what you want is a slightly more detailed mapping of that to an output task. And there, learning learning that function with labeled examples is better.
Interesting. And what was your first reaction to, let's say, ChatGPT, GPT-4, and now 4.0? How did they come across to you?
So I was certainly late to this. I remember when the GPT line of experiments was being done, I I really didn't predict that it would lead to the success that it has, and I put that back even further in the timeline to there was a paper by Richard Socher where who was working for MetaMind, this company that was bought by Salesforce, and the paper was about encoding lots of NLP tasks as question answering. So instead of saying like, all right, we'll have a model that does specifically like part of speech tagging, we'll just have a text to text model, and it will just essentially treat everything like translation or something like this. And I thought, that's a dumb idea. Like, it's so inefficient. Why wouldn't you just have like a specific architecture? And then moving forward, now we have doing everything as text to text without even having this pre-training of it. We just say, all right, it just learns it from the language modeling. So I certainly wouldn't have expected that it would work as well as it has. And I found it quite difficult as like 3 and 4 came out and ChatGPT came out, and I was surprised by the results to actually figure out what my estimation of its performance should be, and like everybody, also figure out like how I should be leading the shot, having been wrong before. Like, how should I adjust my expectations about what's coming and what this means for a future paradigm and that sort of thing.
And, and the other big change which happened is, almost till that point when we would talk about machine learning models as practitioners, you would have very well defined evaluation functions. You would be able to objectively say how
Yep.
good or bad
Yep.
the model is. And with this new kind of regime or new kind of models, that becomes very tricky, right? And then the consistency of the outputs is not there,
Yeah.
and so
So I think an important distinction to keep in mind is, tasks where you're trying to get some structured output, and tasks where you're getting unstructured output. So, and the almost always, if you're trying to feed the output of the system into a further system, like your program has to talk to another program, you almost always want it to be outputting something structured. So there has to be some sort of schema that it's applying labels to, or there's some structure that's going in there and coming out. And so, imagine you've got some system and you're trying to detect fraud or something like this. What you really want to know is what level of alert to raise on this like message you want it, and so that you can then move forward. And ultimately, you might have a whole business process where people look at it, but what you don't want it to do is just output some vague description and say like, oh, how fraudy it looks or doesn't look, or why it thinks that, or something like that. You need something that you can move forward in the system. And if you're producing just text output, then you end up back at the same sort of problem that we had at the start, where you're like, okay, I've got this text, and a human can read it, but what do I do? What do I do with it? I need to actually operationalize it. And so, if we're dealing with those sorts of things of like, okay, we've got a schema where there's something that we have to move forward in a program, and it's something that this is going to connect in a systems way, then no matter how we're building the module that does that, whether we're building it with an LLM, whether we're building it like as a sort of trained model itself, we should want to evaluate it. And so it's really just a process question of saying like, all right, now it seemed like we skipped this step of having to do any annotation of data or any definition of what this means when we went to the LLM, but actually we've kind of got to go back and do that so long as we're dealing with these tasks which are machine facing. Now, on the other hand, when you've got human facing data, this is a whole new um, area of capabilities. These are tasks which weren't well served before, and this is a lot of the exciting stuff. And here, indeed, yes, we've got these problems about evaluation because we don't know what the target should be. So here, I would say doing these sort of structured A/B evaluations or A/B tournaments and stuff like that is what I would recommend for that, and still having like the mindset of a rigorous evaluation and wanting to do things, even if the data points that are counting up are subjective judgments.
interesting. And during this period, while all of this was happening, how has it been for Explosion .ai? How is the business structured now? And can you tell us a bit more about how is it kind of structured, and what are the key areas where you focus on?
Yeah, well, I mean, certainly tons has happened since we last talked, including the pandemic, including like the whole AI revolution, like this whole growth of like the Chat GPT things. So, um, uh, I think overall, our perspective with Explosion is that we started out with Spacey at a different at a time when NLP was a little bit different, and there was a set of concerns, and the library's designed a certain way around that. And we wanted to. I think it's very important as a library that we keep doing the job that we were supposed to do. And we don't say, well, okay, but that job's not as lucrative as some other job over here that's now available, so we should, just change entirely what the library is in order to have something else that's still called Spacey but is like moving into a new territory. That's, I think, something that isn't what the open source community wants to see, and it isn't what we should do. So I think it's important that for Spacey we keep doing what the library was designed to do, and when people need that functionality and people need those capabilities, the library serves those needs well, rather than sort of trying to do some sort of land grab or something like this. So that's one thing that we still believe in Explosion, and we think that the use cases and needs for Spacey are actually increasing rather than decreasing. Like as more people go into NLP and more people need to work with text in various ways, the capabilities that Spacey provides are more relevant than ever. We don't need to say, all right, well, Gen AI is the new hot thing. We need to be like a new LangChain or something like this. So that's one thing. And then the other thing that we're doing, of course, is the annotation tooling. So this is something, as well as Spacey, we think is very important and even more important than ever. So having tooling which really lets you efficiently label data both for training and evaluation is important for so many of these projects. And we want Prodigy to be a small and agile tool around that.
Yeah. And along with this, you also offer very, very specialized consulting services for specific problems. So,
Yes.
so from a business perspective, how is it kind of what's the focus area?
Yeah. So consulting was something that we were doing actually when Explosion was first founded, and we stopped for a while when we released Prodigy, and then we started doing it again a couple of years ago. So one of the key reasons for that is it's very important that we use the tools ourselves, and that we're actually continuing to solve NLP problems rather than just work on the software and only work on problems that we invent or common benchmarks or something like this. I think that really doesn't let us do something that's meaningfully different than the tooling that would be produced in academia, for instance. I think that connection with real problems was very important to Spacey initially, and I think it's eventually that well of like experience that we had working on real problems started to feel like it was running dry, and we needed to have that contact with real problems, and especially as these new methods are available, we need to know, all right, how do we really use LLMs in these ways? Do we, the recommendations that we're making or the ideas that we have, like, we need to be able to actually test those and, keep our hands dirty with real problems. So working on consulting projects is, yeah, it's an important part of the picture for how we develop the tools that we do and how we succeed as a business.
Right. And during this period, you also, obviously released Spacey LLM. Uh, can you kind of describe the exact problem which it is trying to solve, and how is it different from, let's say, the other existing open source LLMs out there?
Yeah, so Space LLM was actually Raphael Mitch's, initiative initially within the company, and then Sophie and others within the company took the idea forward, and so that it's been great to see that grow up, and I think it's like a very useful addition. So briefly, what it does at its core is kind of simple. It gives you, it says, all right, let's imagine the LLM is just like a way of making a classifier. So it's a way of giving you a text classifier or a way of like an entity recognizer or some other module like this. Let's just insert it into the Spacey pipeline. So it encapsulates all of the step of finding the best way to prompt the LLM or parse the output, etc., and puts the annotations onto a Spacey doc object. And then later you can you can replace this LLM powered module with one which you train yourself if you want to. So we think this is especially helpful for prototyping. So if you have this idea of saying, well, I want to have here's the NLP pipeline that I want to get to. Here's I can kind of sub in all of the different modules along the way, even before I have data for them, and have a system that runs. And this might chain together several LLM calls, and it might be super slow. Like in particular, using GPT-4 for classification is kind of problematic. It really is pretty slow, but it lets you get that up and running. And Spacey, it's also helpful in just the way that it lets you interpose rule-based and other classifiers alongside the pipeline. So I think that's also something that's quite helpful with it. So yeah.
Okay, interesting. And so I, before the call, I went to the Explosion.ai site, and there were a few beliefs which you have written on your About Us page, which I found very interesting. So just want to spend a bit of time on some of the beliefs which you have written, and specifically the second belief which is there, and I'll just read it verbatim. The best AI products won't be built from box solutions. Developers need custom models and transparent tools, not just cloud services. Uh, so I can relate to this, and then obviously any kind of very specific tasks, this kind of becomes very relatable. But at the same time, if we look at how some of the proprietary LLMs have come out, they are almost diagonally opposite to these, right? So these are out of box solutions, and you could kind of build over these a bit of opacity in terms of you don't really know how they what data they've been trained on, how they've evolved. Can you shed a bit more light on how you think about it, and then because this has profound impact on how you would build AI.
Sure. I mean, the question of how to see these, the new LLM components that are being released is definitely interesting. So I would argue that, if you take, for instance, the Mistral models that are being released, uh, I think that these are a good example of something where, yes, there's like, some opacity within it. I can't sit down and like, know exactly how this was trained. Maybe there's like, I'm not actually even sure how much information is out there. I think they're reasonably transparent, but still, there's just so much more behind it. And that would also be true for Spacey, for instance. Like people might not know, there's information out there. It's not in as like tidy publication format as it should be about how all the different algorithms work and stuff. But ultimately, there's a level of abstraction that you can go to, and you can say, all right, well, you know, I'm at this point where I've got, these labels on my text, or I know that like I can get these scores or something like this. And so similarly for an LLM component, we can say, well, look, at the end of the day, I know what this thing is supposed to do, and I have the weights. I can, I also understand that, I can add some like adapter heads, or I can, get the vectors and change them in these ways, or I can, do this process to constrain the search so that it generates language in this way that I want. And that ability to actually work at a more detailed level with it, I think, is the key. So the ability to say, all right, this isn't just like, this API that I call where here's the response that I add, and then I get this response back, and maybe it gives me 4 magic parameters that control this or that, and then in some future API version, it's going to change what those parameters mean. That's you can work that way, but I think it is a disadvantage against working against something where you can really build a mental model of what you're actually building against, even if there's a level of abstraction underneath it. So I think that um, what's behind that, that sort of like slogan or thinking or that belief is that there are many there's often in AI this emphasis around how easy something is to start, or how quick it is to get going. And this is important, especially because the at all times, like the number of AI developers is growing a lot. So we've got a lot of at all times most AI developers are still just sort of getting started with things, and so that learning curve is really important. But I think we also shouldn't lose the fact that at a project level, the most important thing isn't necessarily going to be how quick it is to complete, because most projects are going to want to be able to invest more and be able to make the thing better. Especially because you're unlikely to get to this perfect thing in one sitting. So when people are saying like, oh, it takes you could do it in 2 weeks or something. Well, what in engineering is ever built in 2 weeks? Like none of our projects last 2 weeks, right? If you're going to deliver anything, it takes more time and more effort. And so the question is, what does the curve look like as you invest more developer time and more effort into the thing? Can you consistently get it better? And not only that one curve, but what's our distribution of curves? Like how reliably can we run a process with this technology, and how sure am I that I'll be able to invest more and get a better result? And the more that you can take that on, and the more you're working with things that you can have some mental model of, and some things which you can get your hands dirty and work underneath, the better that is. And that's also why I think open source software has worked well, and why it's had that sort of appeal, because it gives you that predictability over time, as opposed to a vendor solution where you might get to a certain point initially, but you don't know what sort of walls you're going to hit.
Matt and many more global leaders in AI are joining us at the Data Hack Summit 2024 in Bangalore from 7th to 10th of August 2024. And if you are an AI practitioner or a thought leader, you cannot miss this confluence of the top minds in AI. Check out the details of Data Hack Summit and book your tickets now. I'll see you at the Data Hack Summit 2024. And now back to the podcast. And when you say custom models, so is it more about changing some of these parameters, or building a model specifically on those use cases? Can you elaborate a bit on that part?
Yeah, um, so it's really about just having this ownership of the process, which means that you're able to adapt the thing as you want. So in many ways, custom models end up, I think, for many problems, it's worth having models which are trained on some specific objective that's specific to your data. So if you're doing classification of some sort and you're producing some sort of structured output, having a model which does what you're trying to do on your data, rather than something which you've tried to download. So if you're doing, say, sentiment of your brand or some articles, if you just download some sentiment model that has been trained on some text, and maybe it does something on those texts, but training on your classes is going to do much better. And even more, trying to understand what are my classes, and should these even be my classes? Should I factor something out and say, all right, I'll learn this simpler transformation and then add these things with some rule based logic or something like that. So that's really that sort of whole experimental step of saying like, okay, how should this actually function? How should I make it work, and that sort of stuff.
So that's more kind of fine tuning, but ultimately you're still kind of building that large model first, and then kind of adopting it or fine tuning it to the specific needs. Is that
Well,
right?
I mean, it depends on how large, we're talking. So you don't necessarily have to start with, an LLM solution with the in context learning. Um, it depends on what your it it depends on where people are coming from in their experience. So I think even aside from Spacey taking up Hugging Face transformers or something like this, and adapting a model from that, I think that the experience for that is sort of satisfying. It's it isn't extremely costly to do that, and the models that you get from that are around like a Birtish size. You know, doing GPU working on GPU can be kind of inconvenient, but this gets you pretty good accuracy, and accuracy that does better than the in context GPT-4, as long as you have at least a few hundred labels usually.
Sure. So going forward, how do you see this mix of small models, but maybe on custom problems versus large models? What are some of your thoughts on how this is going to evolve, and what would,
Yeah,
let's say, models of future look like in terms of size and their use
yeah.
cases?
So there's been lots of different visions of the future of NLP, and uh, one perspective that I do have with this is that if we take the NLP workloads that are in the world at the moment, like being run on these sort of purchase-sized, or in many cases much smaller models. Um, I don't think we'll see those sorts of workloads migrate to something like GPT-4. There aren't enough GPUs in the world to run all the classifiers that we're running in the world today, running them as large language models. And I think that actually we'll run way more classifiers in future. So I just don't see the feasibility of running those things at the sort of GPT scale. I think, and I also don't think that the process of in context learning scales down that much to way smaller models than we see from GPT 3 or 4. Already, GPT 3 really doesn't perform well at these tasks in many cases, and you need that extra size from GPT 4, and even then, many of these classification problems, it doesn't perform that well. So I think if you're talking about these machine-facing tasks, yes, we'll still have these smaller task-specific models. Where I think we'll continue to see great innovation is using large language models and in-context learning to greatly improve the efficiency with which we create those classifiers. So that includes labeling data. It includes understanding what's going wrong during training and that sort of interpretability stuff, or just like general process things. So one of the reasons I think that the in-context learning has taken off so well and has had such great uptake with people is that the process of training your own model does suck in many ways. And one of the ways that it sucks the most is that you start out with these random weights, or at least some of the weights in your model are random. And so you start out at like not a solution, and then you're going to iteratively gradient descent towards something that is a solution. Now, if anything's wrong with that, you get the same result. You get the same sort of error signal, which is, hey, it didn't learn. And so whether you trained on a folder of your cat pictures, or you've got some like key hyperparameter slightly wrong, or you connected up your network wrong, it often ends up looking the same of like, hey, it's not training and nothing's working. And so that's a really rough situation, especially as when you're doing these things and you don't have like tons of experience with it. Starting from a solution that's not working at all and trying to get it to work when any of these dimensions are wrong, you get the same result. That's hard. And so I think LLMs can help with this and start you from a working solution, and you can there's the ecosystem around what that actually looks like in software terms is still undeveloped. I have some ideas and we're working on some things around it, but that's where I think we'll see some great improvements in this. The process of creating those models is not needing so much expertise and not feeling so fiddly and arduous. And so that's something that I do think. The other thing is just the availability of different tasks. So just being able to do so much more, being able to connect these machine-facing outputs to human-facing outputs in like rich and interesting ways, and build pipelines of these things, I think is really cool. And having the ability to generate summaries from a lot of data and that sort of stuff, it really opens up a lot of possibilities.
And how does multimodality sit in this? So do you think that could be a way to kind of get a lot more physical relationships and a lot more relationships into text format? What is your view on
Yeah, so
uh,
the multimodal stuff is another example of a task that was, just sort of beyond the horizon, or things where even if we had the right conceptual framework for it, if the models weren't performing well, then you know, um, uh, it ended up being like, okay, we can't build a satisfying product around this. Now we see those tasks starting to work well at these larger scale, and I think that'll help us build efficient models really well. And so even if you have some use case where you can't afford the inefficiency of sending out the GPT-4, and by inefficiency, I also mean like if you try to actually productionize um, a program which is hitting GPT-4 in the loop, this is really difficult. Like the latency of it is like hugely variant. You can't patch the requests well. It's a little bit better if you use like the Azure APIs or if you use some of the other providers, but even then you get this unreliability and this the models change underneath you, and it's really hard to develop against. Whereas if you once we're in the stage where okay, it's sort of more known and understood, and you can get your own models, and certainly working from the open source ones is a step forward in this respect. I think it's just greatly increasing the range of applications that we can do with that with AI.
Interesting. And any particular thoughts on how this would evolve going forward? So do you still see NLP and text first model in near future, or are we would still see truly kind of multimodal models which are
Well,
almost.
certainly, I think a huge amount of stuff that people want to do with NLP, originates in sort of formatted documents, so PDF and Word things and stuff. And um, this is something which we need to get better at with for Spacey. It's quite awkward at the moment because it can only deal with this textual context and the question of how do you even represent these tables or these whole document layouts and stuff together for classification. So that's something where I see, if we consider that as a multimodal problem of like, understanding a document as a document, whether it's an invoice or like, a CV or anything like that, that's something which, yeah, we're much better off now, and it's sort of increasing, it's improving, and that's stuff which is, continuing to get better. The truly multimodal problems where you really have like text plus image, I think are a little bit rarer in business than things which are working with documents. And I guess these can include sometimes you might have like figures in documents and images and stuff, but mostly understanding formatted text and numbers is, I think, a key. It's a big part of the business need for NLP at the moment, and that's stuff which just having better ability to do that, I think, is really important.
Yeah. The other, you know, uh, 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 not necessarily a trade-off, but a key question in a lot of models has been open source versus closed source. And then we saw OpenAI kind of switching their view about how they should be releasing. There is obviously a lot of believers in open source, and then the benefits which it brings. Uh, just want to know, what are your views, how you're thinking about it, and what are your views specifically around the challenges or trade-offs between this decision?
Well, I think it's definitely something that's a bit difficult in many ways, and this comes up against like different business considerations and that sort of thing. I think in terms of like the user benefit or user advantage, it's definitely beneficial to develop against models which were released, even if you end up using them behind somebody's API. Just the ability to like to have that. To have them available and to know like okay, other people can build on top of it and that sort of stuff. So that's like really helpful, I think. Then on the other hand, you've got things which look what OpenAI provides is more like a product experience, right? Like I use ChatGPT. During my sort of development workflows, I ask it questions about like infrastructure or how do I do this in Bash or something like this, right? So there's a whole product experience side of those things, which is totally different from using it as like a development module. And so for that, this becomes just a business question of whether people want to open source it or not. And I think I'm not the type of open source person who's like, well, this sort of thing should never be closed source. Businesses can develop products on how they want and things. I do take exception to the organizational history of OpenAI and the way that it started out with a certain premise, and then uh, you know that concept has not been how the things are developed. That's something which I wouldn't have done that myself, and I think that that's disappointing. But in itself, like should a business be able to develop this sort of model and release it as a product without open sourcing it? Sure, why not? But at the same time, if we've got a choice to use something as developers, I think there's a big advantage in open source models, and I think we'll be able to do much more. So, and I think that we'll see just much more uptake of the models that Facebook, Mistral, etc., are releasing as open source.
And how far do you think we are, or if you have to put a timeline to when, let's say, the open source models become uh, almost comparable to, let's say, the uh, level of GPT? How far, or A, do you see them converge to same levels, and B, if yes, so when do you think
So
that's
to me, I think this. I'm not as up to date on the detailed evaluation of those things as some other people. So I'm talking a little bit speculatively, and it's a space that changes quite quickly.
yeah,
I would say that it depends partly on what we're considering as up to date, because uh, there's the whole product experience side of using GPT-4 and ChatGPT, which I think is its own animal, and that's where I think there's a lead from OpenAI, and that's where having the usage data that they have and the ability to sort of be the person who sets user expectations and things is advantageous. So they've got a sort of solid first mover advantage in those respects, which is which keeps them ahead for now. Then, if we're talking about just the technical quality of the underlying models, um, again, I'm not the most up to date on this, but my perception is that there isn't a huge gap at the moment between if we're just looking at how accurately these things can understand text and generate text in response. Just they're sort of unaligned without without as much RLHF. Just looking at the models themselves, I think that my impression is that the Llama series and the Mistral series are really getting there. But there'll be other people who can tell you in more detail about this who are working on it currently.
got it, got it. And uh, let's say there are, I have to decide an area of specialization. I want to pursue a PhD and then spend, let's say, time researching in an area. What are some of those areas which you think would become very exciting in, let's say, next 3 to 5 years, where if someone is starting their research work today, they could take that problem and then kind of spend the next few years on it.
Oh, I mean, that's interesting. I don't have any sort of very solid, exciting tips around that. And also, what you study and work on is it's both quite personal, and then also uh, there's a lot of sort of contingent factors in what
Context to
people
it,
end up.
yeah.
Yeah, because ultimately, I would advise any grad student to make sure that they're working on something that their advisor finds exciting.
Hmm.
Because if you working on your own sort of passion project that your advisor doesn't believe in is always I've I've seldom seen that really go that well. And these days you need to work with other people as well. It's very difficult to achieve things independently. So uh, you know it comes down. The other thing is at the moment, grad student positions are so hard to get in AI because it's really quite strange if you think about it that we have this the PhD is used as this professional qualification. And I still think it's a great way to learn, research and things, but it's so bottlenecked by the size of academic institutions because it's tied in with teaching and stuff. So when we have these AI revolutions or this great uptick in the technology, and we say, right, we need this exponential increase in the number of researchers. But then you've got this professional credential which is attached to this other process and just absolutely cannot grow at that sort of pace. It's a strange situation. So we also need to expect that a lot of people are able to get into the field in different ways without a PhD, because it's, a PhD has to mean something in a research context. And, selfishly, as a person, doing hiring, I think it's a credential that's sort of transparent to me, and I understand what somebody's research project means, and I understand it means I can talk to them in certain ways. But as an industry, we have to be able to have people in the field who are doing the same sort of work without, needing that to go through a university system.
Interesting. And then what would those areas be, even if without PhD, if you have to recommend, or areas where you think the next set of breakthroughs could come in? What would those areas be?
Uh, so yeah, I don't have a ready answer for
Sure,
that,
no problem.
unfortunately. So yeah.
Mhm. Okay, no problem. So, specifically for Spacy LLM, how do you see next few years? What sort of areas would you want to kind of build on that?
Yeah, so first of all, there's a lot of things that we just want to make work better, and especially
Hmm.
as the LLMs get better at these classification problems. So uh, there's a lot of NLP tasks which have really suffered from this knowledge bottleneck. So this is kind of why, in many ways, we stopped at something like shallow parsing or at entities and things. There's all of this annotation that we could be doing about semantic roles, or just getting at this basic who did what to whom structured data from text that we haven't been able to produce at scale because the data annotation is so costly. So if we can do that even internally and get those sorts of things running, we can do much better. So having relation models, having text pair models, or ways to understand things in more detail, I think those are all great extra tasks to add to Space LLM. And over time we'll have more multilingual support as well. So at the moment, there's a sort of English specific prompts that are through it, and having equivalent versions of this in other languages, I think, will be very helpful.
Interesting, interesting. And in terms of the usage of Spacy LLMs for on different problems, can you share a few use cases where it has been used, and then the kind of problems which have been solved using that?
Uh, so I think overall, you know, first of all, for open source, you always have this sort of distant view of what people are doing, because they don't
Yeah.
necessarily have to report back that way. I think overall the usage is more around prototyping, and uh, yeah, I don't have a really sort of great use case that immediately comes to mind that I can tell you, but
Sure,
yeah,
sure.
there's definitely a lot of people who are getting value out of it at the moment.
Got it. The other question which I had, and this is, feel free to kind of say no if that is something confidential, because one of the choices you have made is to kind of stay bootstrapped, independent in the way you're growing Explosion.
Oh, so we did actually raise investment money. We're not entirely bootstrapped, no, but we are still quite small, and
Hmm.
uh, we want to make sure that we run sustainably and that we're able to stay focused on what we want to do for the community and what we think is important and useful to do.
Got it. Great, great. Uh, so, Matt, typically towards the end of these conversations, we ask a few rapid fire questions to our guests, and the idea is to just know you a bit better. So,
Sure.
any particular books which had a great impact on you?
Uh, so, uh, well, I'm thinking back to like the things I read in grad school, which were, quite old now. Uh, yeah, I don't have like key recommendations
Sure,
from that.
no problem. What does your typical morning look like? How do you start your day?
So my days are relatively unstructured. I mean, I actually am not the best sleeper, but I sort of wake up and just sort of get on my computer. I work from home rather than an office, so I just sort of wake up and get started. Really.
Interesting. And outside of work, what are some of the other, let's say, hobbies or places where you spend time on?
So uh, I like bouldering, so climbing,
Mhm.
like a lot of other
Oh, wow.
nerds. So I think it's like at least in Europe and the US, it's a fairly popular hobby for
It is.
uh,
Yeah.
yeah. Uh, so and then just getting outside in Berlin is certainly when the weather's good. Uh, you know, yeah, that's mm, not much more to say, I guess. So,
Sure. And
yeah.
what are, let's say, uh, uh, three things you would always carry with you whenever you're, let's say, traveling or
Well,
going
I mean, my constant check is wallet, phone, keys. So,
in?
I am
Okay.
like sort of the absent-minded type. So, just making sure that I'm in possession of my possessions is always like, so that's my mental checklist. Am I leaving
Uh,
somewhere? I've got my wallet, phone, keys, and I don't tend to carry that much around with me.
uh,
Otherwise,
Great.
so.
Sure. Finally, it's great to have you at Data Hack Summit 2024. So can you tell us a bit more about the hack session which you are doing, and what are some of the things which you would be sharing with the audience?
Well, so the topics there are still under development,
Mhm.
but I definitely want to do something in connection with Ines' keynote, and which will outline some sort of more broad ideas around how to structure data projects and different needs for them, and then having the ability to actually get more hands on with that and connect it to a specific example will be really cool because we've often felt this in these conference presentations. It's like, all right, at some point it kind of has to stop, and it's a little bit unsatisfying because it feels so disconnected from something. And so, but on the other hand, giving a the opposite always felt like a little bit narrow. So the ability to actually do both, I think, is really exciting, and we're having fun writing those as we go.
Great. And would this be first time you're traveling to India, or you've been before?
We were lucky enough to go to PyCon India in
Right.
Chennai.
Mhm.
So it's our first time to the north of India, and obviously India is a big country with many sub countries within it, and I'm sure that it'll be quite different. Yeah, we're excited to come.
Great. Thanks a lot, Matt. And then looking forward to your talk and having you at the Iraq Summit. And thanks for taking time out today and sharing those insights with the community.
Uh, my pleasure. Thanks.
Thank you.